Hi, hello everybody. My name is David, aka The Blue, and today we're asked to set up and compute the triple integral as shown here over the hemisphere with equation x squared plus y squared plus c squared equals 25 and has y is greater than 0. So first thing we need to write down is that, or recognize, is that rho squared is equal to x squared plus y squared plus c squared. And here, rho squared is equal to 25, which means that rho is equal to 5. And why this is because rho is our distance between the origin point and this number 5. Now that we know rho, let's find the boundaries for theta and phi. Here I'm going to try my best to draw a graph that shows these three variables. Do know that it's really hard for me to draw a 3D object in a 2D space, but I'll try my best to do it in the best way where I can convey this information to you. But here we have z, x, and y. And theta here, this is going to go from 0 to pi. And the reason that is because if I were to draw this same graph here with just y, ooh, that looked bad, with just y and x, the problem states that y is greater than 0, and when y is greater than 0, theta will only go from 0 to pi. I recognize that on the unit circle, this right here is pi over 2, this is pi, this is 3 pi over 2, and this is 0 or 2 pi, depending on where you start or if you end right there. And it continues on and so forth. Similarly, phi, which I'm going to draw right here, is going to go from 0 to pi. And that looks really wonky there, but let me draw this in a 2D graph where it will be much more easier to understand. So let's say we have z right here and we have y right here. Again, y, it has to be greater than 0. So, and since we're starting off phi from a positive z value, phi, just like theta, is going to go from 0 to pi, since y is only greater than 0 above the z-axis here, and y is only greater than 0 above the x-axis here. And this is how you get your boundaries for rho, phi, and theta just from recognizing what the problem is asking you, and from knowing this either from drawing it out or from knowing what y is greater than 0 entails. But let's say you wanted to solve for this algebraically. So let's write down formula that phi is equal to arc cos of z over the square root of x squared plus y squared plus c squared. Which here for our equation, let's remind ourselves that x squared plus y squared plus c squared is equal to 25. And now the square root of 25 is 5. Here it will be the same as arc cos z over 5. And now let's solve for z. So original equation is x squared plus y squared plus c squared is equal to 25. Let's isolate z squared. 25 minus x squared minus y squared. And this is just the same as 25 minus parentheses x squared plus y squared. And let's recognize that our problem tells us that y is greater than 0, so the value y squared also has to be greater than 0. And x squared, because any value x is going to be squared, negative or positive, is just going to turn up as a positive value in the end, can be greater than or equal to 0. And what this tells us that x squared plus y squared right here, and let me redraw that, has to be greater than 0. So when we plug this back into original equation right here, this means that 25 is always going to be subtracted by a number greater than 0, which means that z squared has to be less than 25. And when we square root this, we get the interval -5 is less than z, which is less than 5. And this is where we use our formula for phi, where here it's z over 5. So we're going to match that here to our interval. So we're going to divide everything by 5. So -5 divided by 5 is -1. Z divided by 5 is z over 5, just like shown up there. And 5 divided by 5 is just 1. And now we're going to find the inverse cosine of those very same things. So arc cos -1, and we'll also be switching signs with this. Arc cos, and let me write this further down so I have more space. -1 is greater than arc cos of z over 5, which is greater than arc cos of 1. And plugging this into our calculator, or if you know these values from heart and just a ton of practice, this gives us that pi is greater than phi, and recognize that this is just this up here, which is greater than 0. And rewriting this in standard format will be 0 is less than phi, which is less than pi. And that sounded like 5, but I said phi. Yeah, that's just another way to solve for your boundaries. So what this gives us is that the triple integral over the region D of x squared plus y squared plus d squared squared dv will be the same as, and this right here, this is rho squared squared again. So this is going to be rho to the power 4. And let's not forget our Jacobian when switching to spherical coordinates. So this will be times rho squared sine phi. And I realize I wrote this a bit too small. D rho d phi d theta, with our boundaries being 0 to 5, 0 to pi, and 0 to pi again. Now let's go ahead and solve this. I rewrote this as rho to the power 6 times sine phi, and the reason I did this is because rho to the power 4 times rho to the power 2 is just going to be rho to the power of those exponents added based on exponent rules. So let's go ahead and solve this integral. I have 0 to pi, 0 to pi, and then we're going to erase rho to the power 7 divided by 7 sine phi from 0 to 5 d rho d theta. This right here, when we plug in 5, it will give us, and I don't have this in the top of my head, so my calculator gave me 78,125. So this will be 0 to pi, 0 to pi, 78,125 over 7 times sine phi minus 0 to the power 7, which is just 0, divided by 7 sine phi d phi d theta. This right here is 0, so we don't have to worry about anything when it comes to that. So this will be 0 to pi, 0 to pi, and let me actually take out that number out here. 78,125 divided by 7, 0 to pi, 0 to pi, sine phi d theta. This, the antiderivative of that will be 0 pi of negative cos phi from 0 to pi d theta. Now plugging in pi into cos, that's going to give us -1, and plugging in 0 into cos is going to give us 1. So this would be negative, well, let me just write this up here, -1 minus -1, which this right here, this is just 1 plus 1. So we're going to get 78,125 sevenths from 0 to pi of 2, whoa, that is not a 2, 2 d theta. And let me bring this up here to the top. We can take out the 2 and just multiply our coefficient by 2, so that will give us 156,250 divided by 7 from 0 to pi of 1 d theta, which the antiderivative of that is just data from 0 to pi, which, oh my goodness, I'm getting a bit too close to that number. My bad, guys, if this is a bit messy. I'm not that used to doing problems on my iPad. But this would just be pi minus 0, which is just be the final answer of 156,250 over 7 pi. And I worded that incorrectly. It's 156,250 pi over 7. And yeah, that is how you set up the integral and solve it. So yeah, I hope you guys enjoyed and that this helped out with any math questions regarding questions like these. But yeah, I'm back and I hope to see you guys again. Thank you.